All right, the next lesson in Algebra 2 is called Solving Rational Equations. Okay. So this first definition is going to be a rational equation. It is an equation that contains one or more rational expressions. Rational equation. To solve a rational equation, start by multiplying each term of the equation by the least common denominator, LCD, of all of the expressions in the equation. Okay? This step eliminates the denominators of the rational expression and results in an equation that you can solve by using algebra. Okay? This next definition we've talked about before, an extraneous solution. Extraneous solution is a solution of an equation derived from an original equation that is not actually a solution of the original equation. Okay? When you solve for a rational equation, it is possible to get extraneous solutions. These values should be eliminated from the solution set. Always check your solutions by substituting them into the original equation. Okay, so here we go. Example 1, solve for x. X minus 18 over x equals 3. Okay, so we're going to try to find the LCD, the least common denominator. Now, this one's actually pretty easy to get the LCD. There's only one denominator, so my least common denominator, my LCD, is going to be equal to x. So now what I'm going to do is I'm going to multiply each term by the LCD. Okay, so I'm going to do x, my LCD, x, times the first term, which is just x, minus the LCD, I'm doing that in blue, the LCD times the second term, equals the LCD times the third term. Okay, so I'm trying to do the LCD in blue so you can see the difference. What I did was I took my LCD, my least common denominator, which is x, and I multiplied it by all the terms in the original equation. All the terms, every term. Not some of the terms, all the terms. Okay, let's see what we get. X times x is x squared. Minus. Again, the point of doing this is to eliminate all the fractions. X times 18 over x, the x's get eliminated, so you have x squared minus 18 equals 3x. Now we're going to solve this. We've done solving quadratics a lot this year. What I'm going to do is I'm going to get it equal to 0. So I'll bring the 3x over, and I'll write it in standard form. Now I'm going to try to factor. So what two numbers multiply to negative 18 and add to negative 3? It'll be x plus 3 times x minus 6. That's how you factor equal to 0 and solve. X plus 3 equals 0 gives you x equals negative 3. X minus 6 equals 0 gives you x equals 6. Now we're not done yet. Okay, we are not done yet. So here's what I'm going to write down. Make sure your answers don't make a denominator equal 0. Make sure your answers don't make a denominator equal 0. exclamation point. If your answers do make a denominator equal 0, then that is called an extraneous solution. Okay? So in this case, x minus 3, x equals negative 3, that does not make any denominators equal 0. And if you want to double check it, it's not a bad idea. If you do x equals negative 3, you're going to have negative 3 minus 18 over negative 3. So it'll be negative 3 plus 6, which equals 3. That one works. And for the solution, x equals 6. That does not make any denominators equal 0 either. So that one's going to be fine. Well, let's just double check. 6 minus 18 over 6 is the same as 6 minus 3, which equals 3. Okay? Neither answer makes a denominator equal 0, so I'm going to circle both of them. If one did make a denominator equal 0, then you would just disregard that. That is not an actual solution. That would be an extraneous solution. We'll see that later on. Okay, let's try example 2. The least common denominator for this one is going to be 3 times x. Think about it. You have an x there, you have a 3 there. So the least common denominator is going to be 3 times x. So what I do is I multiply each term by 3 times x. Okay, so 3x times the first term. I'll do that in blue again. 3x times the first term. Plus 3x times the second term. Equals 3x times the last term. Okay, so again, I'm trying to do that in blue so you can see what I'm doing. And again, the whole point of doing that was to eliminate the fractions. So 3x times 4 over x, the x's divide out, and you have 12 plus 6x. Okay, the 3's are going to multiply out on the right, or divide out, and you get equals 10x. Do all the x's on one side, so subtract 6x, 12 equals 4x, and you get 3 equals x, or x equals 3. Now, before I circle that, we have to make sure our answer does not make any denominator equal 0. I'll jot that down again. Make sure your answer does not make any denominator equals 0. Now, I know this one works, so I'm just going to circle it already. Okay, but as you can see, if I substitute 3 into all my denominators, none of them become 0. If I got x equals 0 right there, that would be no good because that would make that denominator equal 0. So I would not circle that if that was an answer. But x equals 3 does work. And if you want to double check, 4 over x is 4/3. 4/3 plus 2 is like doing 4/3 plus 6/3, which equals 10/3. That also works. Okay. Okay. Time for one that's a little more difficult. The least common denominator here is going to be 2 times x minus 8. What I'm going to do is I'm going to multiply each term by the LCD. I'll try to do that in blue again. 2 times x minus 8 times the first term. Plus LCD times the second term equals the LCD times the final term. Okay. So far, all I did was I multiplied the LCD by every term. Okay. Now the LCD is 2 times x minus 8. So that's why I'm doing 2 times x minus 8 times each term. That should eliminate any fractions. Okay. Because for my first term, the x minus 8's divide out, and I'm left with 2 times 2x minus 5. For my second term, the 2's divide out, and I'm left with x minus 8 times x. I'll put the x first so it looks nicer. And for my last term, the x minus 8's divide out, so I'm just left with 2 times 11. Okay, let's see what we got. We're going to have to distribute 4x minus 10 plus x squared minus 8x equals 22. So combine like terms on the left, we get x squared minus 4x minus 10. I'm going to try to solve this by factoring, so I'm going to get it equal to 0, subtract 22 on each side, x squared minus 4x minus 32. And I didn't mention how important factoring is, how it would come up throughout the year. Now we have to factor this. What two numbers multiply to negative 32 and add to negative 4? It'll be 4 and negative 8. So I factor it to x plus 4 times x minus 8. X plus 4 equals 0. X equals negative 4 when you solve that. X minus 8 equals 0. X equals 8 when you solve that. Now let's check each answer and let's make sure that they work. Okay. Negative 4. Does negative 4 make any denominators equal 0? No, it doesn't. Okay. Negative 4 does not make any denominators equal 0. And if you want to double check it to make sure that it works by substituting negative 4 in for all the x's, it does in fact work. Okay. But it does not make any denominators equal 0, so this isn't going to be a solution. So I'm going to circle it because that is a solution. However, x equals 8. Does that make any denominators equal 0? Yes. When you substitute x equals 8 here, you get a denominator of 0. And you also get a denominator of 0 here too. So that means it's not actually a solution. It's called an extraneous solution. Okay, so let me just jot that down. This is an extraneous solution, which we talked about on the first page. Okay, so just flip back to the first page if you forgot what an extraneous solution is. So I'm going to say this is an extraneous solution because it makes a denominator equal 0. Exclamation point. I'm going to say don't circle it. Exclamation point again. Because it's not actually a solution. It's called an extraneous solution, so it doesn't actually work, so don't circle it. Okay? 2 more. Okay, so this next one is actually easier than it looks. Okay? Whenever you have a rational equation like this, where it's just, like one term equals another term over another term, you just have to cross multiply. Okay, think about Algebra 1 and geometry. You solve the proportions a lot. Whenever you have a proportion like this, just cross multiply. I'll jot that down. Just cross multiply for this one. Just cross multiply for this one. So 5 times x squared minus 1 equals 15 times 2x minus 2. Distribute on each side. 5x squared minus 5 equals 30x minus 30. Okay, let's get this equal to 0. So I'll subtract the 30x. 5x squared minus 30x. I'll add the 30, so I'll get plus 25. Now again, there's more than one way to solve these. So you could solve these by either factoring, okay, if you can factor, or you can use square roots. That's handy if there's no x term, usually. Or you can use completing the square. That's good if it's 1x squared, though, and the b term is even. Or you could use the quadratic formula. Now, the quadratic formula always works, but that's usually the longest way. Okay, but this one I can factor, and it'll be very it'll be much faster if we take out the GCF of 5. If we factor out the GCF of 5, it leaves you with x squared minus 6x plus 5 equals 0. Now let's factor that. Let's find two numbers that multiply to 5 and add to negative 6. It'll be x minus 5 times x minus 1. Set each factor equal to 0. 5 equals 0. You can ignore because 5 cannot equal 0. Then you have x minus 5 equals 0, which means x equals 5. Then you have x minus 1 equals 0, which means x equals 1. Now let's check to see if either one of those solutions is an extraneous solution. Does either one make a denominator equal 0? Let's start with x equals 5. 2 times 5 is 10, minus 2 is 8, so that does not equal 0. That's great. 5 squared is 25, minus 1 is 24. So that does not equal 0 either. Both of those are fine, so x equals 5 works. Okay. And again, like I just mentioned, we basically just checked it because we did 5 over 8, and then we had 15 over 24, which simplifies to 5 over 8. So x equals 5 works. That's good. I circle that. X equals 1. Does that make a denominator equal 0? Yes, because look, 2 times x, 2 times 1 is 1. And 2 times 1 is 2. Minus 2 equals 0. And the other one also doesn't work because 1 squared is 1, minus 1 equals 0. But as long as one of them is 0, then it means it does not work. Okay? I'm going to say, I'll jot that down too. I'll say this is an extraneous solution. Because it makes a denominator equal 0, don't circle it. Exclamation point, don't circle it. Exclamation point. All right, one more. This one had, example 5 has the least common denominator equal to x times x plus 1. So we're going to multiply each term by x times x plus 1. X times x plus 1 times the first term minus x times x plus 1 times the second term. So again, I'm trying to put the LCD in blue so you can see what I'm doing. Equals the LCD, x times x plus 1, times the last term, which is 1. Okay, hopefully this eliminates the fractions. That was the point of doing that. So the x's are going to multiply out here, and you're left with 4 times x plus 1. Minus these x plus 1's multiply out or divide out, and you're left with 3 times x. Equals, you can ignore the 1, equals x times x plus 1. Okay, let's keep going. Let's solve that for x. Distribute 4x plus 4 minus 3x equals x squared plus x. Now, let's combine the terms on the left to get x plus 4. Now, generally when you're solving a quadratic equation, well, actually, you know what? Let's subtract the x on each side. Let's get 4 equals x squared. And let's rewrite it with the x squared on the left so it looks nice. Solve that for x. Take the square root of each side. Positive and negative on the right. Square root of 4 is 2. So x equals positive and negative 2. Let me rewrite it like this. You can circle that if you want, as long as they both work. I'm just going to write them as 2 separate answers, and let's check each one separately and see if they work. X equals 2. Does that make any denominator equal 0? No, because this one will be 2, and that one will be 3. And it works if you really want to check it over to see. X equals negative 2. Does that make any denominator equal 0? No, because this will be negative 2. That'll be negative 2 plus 1, which is negative 1. Neither one is 0. So this one actually works. If you want to check it, you can. But neither one is an extraneous solution, so I circle them both. Okay. So that's the end of that lesson. Solving rational equations.